Hello friends, my name is Shekhar. Hope you all are doing well. In this video, I will take you through quality tools. I hope you found my last video on evaluation of quality management helpful. If you have not watched that video, then I recommend you watching the same, as there is a distinct relationship between the tools and march up quality. 7 basic quality tools, also known as TQM tools, are flowchart, checksheet, histogram, Pareto chart, fishbone diagram, scatter diagram, control chart. Now let's look at them one by one. First one is flowchart. A flowchart is a process map that identifies the sequence of activity needs to be performed completing the task. Flowchart serves as a training tool, shows unexpected complexity, problem areas, redundancy, unnecessary loops, and where simplification may be possible. Allows the team to reach agreement on process steps and identifies activity that may impact performance. While we use flowchart, it is also important to know each shape are being used for a specific purpose. For example, first shape is a rectangle with two sides rounded, signifies start or end of a flow. Next one is a standard rectangle and it implies to process. This one is for decision and then data, documents, and so on. Now let us see the next tool, checksheet. Checksheet are a special type of data collection form in which the results may be interpreted on the form directly without additional processing. Checksheet can be used to keep track of defects. If you remember, we discussed inspection as a first footstep in evaluation of quality management. This tool is heavily used in inspection technique. As a QA for service centers, you are often asked to do scrubbing for finding specific defects, which is similar to filling a check sheet. Moving on to the next tool, histogram. We all know about bar graph. The histogram is a typical bar graph that identifies the frequency of quality defect occurrence and displays quality performance. It shows the pattern that would be difficult to see in ordinary table format. Histogram plays a key role in SPC or statistical process control. Histogram shows centering, variation, and shapes, illustrates the underlying distribution of the data, provides useful information for predicting future performance, and not to miss, helps to answer, is the process capable of meeting requirements? Now let us discuss Pareto chart. A Pareto diagram is named after Vilfredo Pareto, an Italian engineer and economist. His observation was 80% of the land in Italy was owned by about 20% of the population. A Pareto diagram is a histogram of the data from the largest frequency to smallest. It helps to identify the most important defect that needs to be controlled. Pareto principle is also known as 80-20 rule. It is said 80% of the problem may be attributed to the 20% of the causes. Pareto analysis played a key role in DOE or Taguchi method. Fifth tool on the list is cause and effect diagram or fishbone diagram. It is named after its fishbone shape. This was pioneered by Ishikawa, also known as Ishikawa diagram. Fishbone diagram is a powerful tool for root cause analysis. It systematically tracks backwards to find a possible cause of a quality problem and not the solution. It works on the principle of generating idea. Few commonly known methods for generating ideas are brainstorming, quality circle, interviewing, benchmarking, and 5W2H question. Next tool is scatter diagram. A scatter plot is a type of plot or mathematical diagram to display values for two variables of the dataset. We can use it to plot one function as fixed and other being variable or both being variable. This tool was used to find the individual relationship between process waste and impacting factors during SPC. Last tool on the list is control chart. Control charts are also known as Shewhart chart, named after Walter Shewhart. It is a statistical process control tool used to show the performance of a manufacturing or business process. Let me go back to my favorite process distribution image. This distribution can be shown by control charts. Upper spec limit and lower spec limit is plus minus 3 times of the standard deviation of the target. With this, we come to the end of this session. Thanks for watching. Leave your comments for any question or suggestion.